Good day, class. In this lesson, we will practice solving quadratic equations using completing the square method. Keep in mind that there are multiple methods by which you can solve a quadratic equation. Here, we're going to focus on completing the square. Notice I've bolded the completing the square method and quadratic formula method because those are the methods which can solve every quadratic equation. However, we're going to focus in this lesson on using the completing the square method. First, though, you'll need to recognize a perfect square trinomial. Here you're looking at a perfect square trinomial, x squared plus 2x plus 1. So if you're ever feeling frustrated with dealing with completing the square method, you can probably point back to your ability to recognize or not recognize a perfect square trinomial. So again, if you're ever struggling with completing the square method, or if you're finding yourself hating it, I really strongly urge you to change your mind and just take the time to recognize and manipulate a perfect square trinomial, and that will clear up whatever problem you're having with completing the square. So let's talk about this perfect square trinomial for a minute. We know we have a trinomial because we have three terms. X squared is our first term, 2x is our second term, and the 1 is our third term. Notice how those terms are moving down in descending order. The first term, x squared, is a perfect square, x times x. The third term, 1, is a perfect square, 1 times 1. Those are required in order to have a perfect square trinomial. Your first term and your third term must be perfect. Also, your middle term and your third term must have a very unique relationship. In fact, half of the middle term squared must create the third term. In this case, half of 2 is 1. If I square the 1, I get the third term. So I know I have a perfect square trinomial. Whenever I have a perfect square trinomial, now remember the first goal was to recognize a perfect square trinomial. In some cases, you'll create a perfect square trinomial. However you get to that perfect square trinomial, at that point, you're 75% of the way there in dealing with your quadratic equation. When you have an equation, notice this is an expression. So I'm going to rewrite this perfect square trinomial whenever it's convenient. Sometimes I need my perfect square trinomial to be written in this form because x squared plus 2x plus 1 has the same exact value as x plus 1 times x plus 1. Okay, so I can multiply those binomials. So keep in mind that you can always rewrite a perfect square trinomial, and that's the key, in its binomial form. Here I've written it as x plus 1 times x plus 1. The x comes from the root of the first term, and the 1 is the root of the third term. So x times x, 1 times 1. So I have two of those binomials here. I can also write it in a binomial squared form because x plus 1, that quantity times x plus 1, is x plus 1 quantity squared. So knowing that you can write a perfect square trinomial in any of these forms, or you can take an perfect square trinomial and write it in its binomial squared form, is really important. So once you do that, from there, the sky's the limit of what we're able to. Here's a perfect square trinomial. My first term is perfect, x squared. My third term is perfect, 144 is 12 times 12. And then my middle term and my third term have a unique relationship. Half of 24 gives me 12, and if I square that 12, I'll get the 144. So once I have three terms and all those other key elements have fallen into place, I know I have a perfect square trinomial. If I have a perfect square trinomial, I can rewrite it in either of these forms depending on what is most convenient for me. Here's one last example to recognize a perfect square trinomial. I have x squared is my first term. I have a middle term, and I have my third term, which is also perfect. It's 9, which is 3 times 3. And then my middle term and my last term have a unique relationship. Half of 6 is 3. 3 squared is 9. I definitely have a perfect square trinomial, which means I can write it in its binomial form or its binomial squared form. Whatever is most convenient for me when this expression is contained inside of an equation. Now that we understand how to recognize a perfect square trinomial, let's understand how to create one. Here we have an equation. I know it's an equation because there's an equal sign present. I also know I'm dealing with a quadratic equation because the highest power of my variable is squared. And I just have one variable present here. Keep this in mind because recognizing what type of equation or expression you're dealing with sometimes is half the battle. So I have a quadratic here. I'm choosing to solve by way of completing the square. So really what I need to do is make space for a trinomial. Notice how I kind of slid the x squared plus 6x a little bit to the left to leave a space for that third term. There is no trinomial without 3 terms. And I just let that -5 hang out. I need something to go here. I need that third term to go here, but I need it to be a unique term. Remember we talked about the uniqueness or the unique relationship between that second term and that third term? Well, I'm going to create half of 6 is going to give me 3. I'm going to square that 3. I'll get a 9. So clearly a 9 can go in that blank space. So what used to be blank is now a 9. But notice how I've added 9 both to the left side of my equation and to the right side of my equation because I have to keep my equation in balance. So keep that in mind at all times. I purposely selected the number I want to add to both sides of the equation because that number will create a perfect square trinomial. Once I've done that, I can rewrite my trinomial in whatever form that's most convenient for me. I find the binomial squared form to be very convenient. Why is that most convenient? Because I can take the square root of both sides because I have a perfect square on the left side of my equation, the side that contains my variable. If that is a perfect square, it gives me access now to that x, which was at first a squared value, and now I've manipulated this equation using a perfect square trinomial to get at that variable x. Many times the goal of solving an equation is just getting back down to that first level, linear level equation. Now I have a linear equation I could solve all day long with no challenges. Keep in mind that taking the square root of that 4 is also going to yield me a plus or minus 2. A positive 2 or a negative 2 could have resulted in that 4. So I'm going to take a look at both possibilities. X equals -3 plus 2 and x equals -3 minus 2 to isolate my variable, which would yield 2 potential solutions, and then I can plug both of those potential solutions back into the original equation, x equals -1, x equals -5, to see if both or either or neither make a true statement for my original equation. But at any rate, I have actually solved that equation.